SQL started to become popular, people wanted to get away from file-based data management and management of specialized structures and so forth and objects, and get into a more structured relational way to manage data. And that's what SQL means. It's a structured query language was the original name for it. And at the time when the RDBMS was designed, the hardware that implemented relational databases was significantly different than the hardware that is available now, or even already 10, 11, 12 years ago when we started thinking about redoing the database, the hardware was already very different. And how was it different? If you look at this picture, typically in computers we have CPUs, we have main memory, and well, actually there are layers in between as well, the onboard caches and so forth. And then there is the disk. And memory, accessing data from memory is dramatically faster than accessing it out of disk. Something like 10,000 times or more faster. So this is slow and it is ugly and we don't like it. And the other thing that happened was, so this was not clear in the days of the relational database when it was first built. The DRAM was much more expensive and much smaller than it is now. It was millions of times worse in price performance than it is now. Also, the other fundamental thing was that CPUs back then were single core, and so Moore's law was largely attained because of improvements in the single core CPU itself. And already by 2003, it was clear that this was running into a physical wall, into a hard limitation governed by things that we cannot control, like the speed of light and things like that, the processors were not going to be single core anymore in order to continue the performance and manufacturing benefits of Moore's law. So already by 2003 or so, it was clear that a completely new kind of a database paradigm was within our reach. And when we started thinking about this, it became clear that if SAP has to build a new database, then it has to be built around the new reality of hardware. That is multi-core processing, a massively larger and cheaper main memory, and the advent of columnar structures. The reason why columnar structures are interesting is because already by that time, about 10 or so years ago, OLTP and OLAP had become very different kinds of industries, in fact. A set of companies were building things for OLTP, for transactional applications, and another set of companies were starting to build things primarily for OLAP, for analytics. And analytical workloads are quite different than OLTP, or at least this was the assumption, this was the belief that everybody in the industry had, that you're either analyzing things or you're writing things, and these two things are very, very different. Nevertheless, the columnar databases were invented, columnar structures were invented to store the same relational information, but to be able to retrieve them significantly faster. And columnar technology itself is not new. Databases like, for example, our own Sybase IQ are more than 20 years old, and for a long time people have known that columnar databases are better for retrieval performance. In the case of Sybase IQ, it is a disk-based columnar database, and this is more than 20 years old now. So by this time, it was clear that columnar databases offer some unique advantages for improving analytical performance, as well as multi-core processing and large availability of larger quantities of DRAM. So when we looked at this, when I started thinking about this back in 2002, my first conclusion was that SAP had to build a new database. The reason for it was very straightforward. Among other things, first of all, a completely new paradigm in databases is possible. Good news was that SAP had worked on database technology for quite some time. So if you look at the timeline of where we have been, way back here in the past was 1977, and Rudi Muntz did his thesis and built a database that we all know now as MaxDB. And around 1999, Franz and some of his friends started to build T-Rex. And I joined in 2002, and I started thinking about one of the first projects that Hasso asked me to think about was databases, and some of the work that Franz had done was already known by that time. I went and I talked to one of my PhD advisors, Geo Wiederhold, and he introduced me to Sang Cha, who was also his student, and Sang had been working on a technology called P-Time, which was a in-memory row store technology, a sort of a second generation database. And Franz and Stefan and the guys built the Euclid project, which was demonstrated and was the winner of the very first DCOM that SAP ever did back in 2003. When Franz showed the Euclid running 1 billion records in 1 second, that was pretty remarkable. So Hasso started to teach these things at HPI around 2004 and started to launch a real investigation into how all of these things could be combined into a full database. And in August of 2006, about 30 meters from here in his office, he told me about this idea that he had, that we could rewrite financials. And he wanted to rewrite financials for the 4th time in his life. And this time, because of this amazing ability to calculate things on the fly and the dramatic performance that we get from this new database technology, that we could actually get rid of all the aggregates. And his guess was 70% or so of the code in financials was about creating and managing these aggregates, indices, daily totals, weekly totals, monthly totals, things of this sort. And I remember that night as I was driving home, I had just come back from Hawaii, and as I was driving home that night, it was very clear that this was a fundamentally new idea, not only in databases, but in how we can apply the database to rethink the architecture of the application itself. And so that night I thought of the name HANA as Hasso's new architecture. That's sort of where the HANA name comes from. August 2006, right here in Palo Alto. And so we started working on that. In 2009, Hasso presented his paper on the in-memory database, this columnar in-memory database at VLD, at SIGMOD in New England. It was extremely well received. That fall, we started the HANA development project for building the HANA product. October of 2009. On December 1st of 2010, we launched HANA. It went into RTC, and then June 2011, HANA went generally available. So that, boys and girls, is a little history of how HANA came to be. So HANA became generally available in June of 2011, shortly after Sapphire. Back then, at Sapphire, I had showed the first 25 or so customers that we had worked with who were starting to do all kinds of amazing things with HANA. And since then, it has been an unbelievable journey. HANA became the by fastest growing product in our history. By my calculation, also in the history of enterprise software. As we are taping this, it is September of 2013, so it's about 2 years and 3 months since the launch of HANA. It's exactly 2 years and 3 months. It was June 20th of 2011 that HANA became generally available. So 2 years and 3 months ago, and in those 2 years and 3 months, HANA has already made more than $1 billion in revenue. $1 billion, yes, that is one with 9 zeros in 2 years and 3 months. That's pretty unbelievable. And more than 2,000 customers have already purchased HANA. We have something like 1,100 implementations going already. And it has just been a hell of a journey since then. Beyond the customers, 10 different hardware vendors are manufacturing hardware for HANA. HANA itself is the result of a deep collaboration with Intel. It's something like that, Intel inside, right? It is now 10 years since we started working with Intel. I remember when the first Woodcrest chip came out, which had the 2 CPU cores. And Daniel Schneis had called me and told me that T-Rex was running something like 85% faster because it had 2 cores. We just recompiled the software for the Woodcrest chip, and actually it was the same code. And then it was clear that this multi-core benefit that we get from HANA was something that was going to really. So thanks to our friends at Intel, you are the best. And without you guys, HANA would not be possible. So 10 hardware vendors: Intel, IBM, HP, Cisco, Fujitsu, Dell, Lenovo, Hitachi, all kinds of companies are making servers for HANA. We have all kinds of storage partners and stuff like this. Almost 10,000 different consultants from around the industry have been trained on HANA. It's quite spectacular. And all kinds of companies in the ecosystem are building applications on HANA, are building all kinds of services, education, consulting, training around HANA. So it's been quite an incredible journey. SAP itself, we have now 77 products of ours that run on HANA, and every single product either already runs on HANA or is in the process of running on HANA. And one of the most amazing things that our team did recently that we are really proud of is ISP. Our internal ERP system now runs on HANA, and this has basically more than 60,000 users in our company. Our whole company depends on the ISP system, and ISP now for the last roughly 5 weeks has been running on HANA. So that is something, quite an amazing testament to the fact that to this product. And it was originally supposed to be simply an analytic. Everybody used to think that HANA is an analytical product, but to see that one of the world's most mission critical, most complex, large scale ERP system, including our own of a very large company, is running on HANA. Knock on wood, in the next 10 days, we'll be closing our own books on HANA for the very first time. And we are one of about a dozen companies right now that are running their own ERP systems on HANA. So this is something quite extraordinary.